All right, I'm going to be showing you today something called the law of sines. Now remember, when we have similar triangles, the sides are in the same ratio. So there's always a relationship between the sides and the angles. Well, law of sines takes it one step further and says we can have a relationship between sides and angles even when it's not a right triangle. Now the relationship it gives us is this rule. So I'm going to write it in dark blue. Okay, so the sine of angle A over little a. So the sine of angle A over the side across from it is the same ratio as the sine of angle B is to little b. So angle B and the side across from it. And guess what? That ratio is the same as the sine of angle C is to little c. Now I could do a proof of this if you would like. Just ask me and I will record a proof. But otherwise, it's pretty nice. So when we're asked to solve a triangle, that means I'm going to find everything that's missing. So I'm going to draw my picture. A, B, C. So I name the angles with big letters, and the little letters are for the sides, and they're always across from their angles. So big A, big B, big C, little c. Now let's label what we know. Angle A is 75 degrees. Angle B is 60. I bet we could find angle C. Angle C would be 180 minus 75 minus 60. It would be 45 degrees. So I also know that side C is 34. So I know angle C and side C. I know angle C and side C. So I'm going to start with the sine of C, and I'm not going to do the parentheses right now just to set this up. Sine of A over little a. Now just remember, every time you do this, your angle will always be in parentheses. I'm just being a little lazy. So sine of 45 over 34 is going to be in the same proportion as the sine of angle 75 degrees is to the side across from it, which is little a. Now to solve this, all we have to do is some cross multiplying. So I'm going to multiply both sides by A and then both sides by 34. So I'm basically cross multiplying. So A times the sine of 45 equals 34 times the sine of 75. And then I would just need to divide by that sine to get A by itself. Now be very careful here. The signs do not cancel out. They belong with their angle. They stick together. That's why the parentheses are there. So do not try to cancel out the signs. That does not work that way. So 34 sine of 75 divided by sine of 45. And it says that that is 46.445. So little a is 46.445. Now I'm not done because I also need side B. Now I really don't want to use little a because it's an ugly number. So I'm going to use sine of C again over side C. And then I'm going to put on the other side, instead of A and A, I'm going to use B. So sine of B over little b. And again, I would need to cross multiply. So b times the sine of 45 equals 34 times the sine of 60. divide by the sine of 45. Again, the signs do not cancel out. So I would have 34 sine of 60 divided by sine of 45. And that is giving me 41.641. So now we have found all the angles and all the sides of a non-right triangle. Now, to do this, we really do need to know at least one side and the angle across from it to use this law of sines, because we have to at least have one of these ratios known. Okay, our next one, I'm going to draw my picture a little bit smaller. A, B, C, little a, little b, little c. Angle A is 20. Angle C is 25. I bet we could find angle B. So 180 minus 20 minus 25, I get 135. So my picture's not good, because 135 should be an obtuse angle, but that's okay. Side C is 80.4. So again, I know C and C. So the sine of big C divided by side C. I think I'm going to do A first. So sine of angle A over side A. Again, we're going to do some cross multiplying. So A times the sine of 25 equals 80.4 times the sine of 20. Then I would just divide by the sine of 25. $80.4 times the sine of 20, sine of 25, and I got 65.067. Oh, I forgot to write down, we found angle B. It's 135. So everything I found, I'm kind of boxing so I know which ones I found. I also need to find side B. So let's use the sine of angle C over side C, and then the sine of angle B over side B. And cross multiply. Last example on this, I believe, nope, it is another example using the same idea. So a satellite orbiting the Earth passes directly overhead at observation stations in Phoenix and Los Angeles, and those stations are 340 miles apart. All right, so we have a picture, and mine's on the next page because it kind of messed up a little bit, and here's the 340. And they're calling that side C, so that makes this angle C up here. Angle B is here, angle A is here. So it says that the angle of elevation at Phoenix is 60 degrees, and the one at Los Angeles is 75 degrees. And then it wants to know how far is the satellite from Los Angeles. So here's the satellite. Los Angeles is here, so that would be little side B. So I'm trying to find We're trying to find side B. And all I know is side C, so I better know angle C. Well, 180 minus 75 minus 60, I get that angle C is 45 degrees. So I'm going to use sine of C over little c equals sine of big B over little b. So sine of 45 degrees over side C equals the sine of 60 over side B. And use some cross multiplying. And what I would end up getting is 340 times the sine of 60 divided by the sine of 45. And that would be 416.413 miles. All right. Now, the next example is when we have two sides and the angle opposite one of these sides. We can actually draw two different triangles. So let me show what I mean by that. So I know angle A is 43.1 degrees. So that's a small angle. Angle A is 43.1. And side B I'll make this be B, is 248.6. That makes this angle B. So one option is that angle B is acute. Now all I know so let's start with finding angle B. So I'm going to do sine of A over little a equals sine of B over little b. And so I know angle A and side A. And I don't know angle B, but I do know side B. And so I can do my cross multiplying again, but this time I'm going to end up with 248.6 times the sine of 43.1 divided by 186.2 equals the sine of B. Well, if I find that left side, 248.6 sine of 43.1 divided by 186.2, that is not giving me my angle. That is just giving me the ratio. I need to find angle B. So this is when I'm going to use the arc. So shift sign, and you can just press answer and it'll use the last answer. And that gives me 65.819. So we're using angle B as an acute angle. Now from here, I would find angle C, which would be very easy because we would just do 180 minus 43.1 minus 65.8. And so angle C is 71.1 degrees. I'm just kind of rounding up just to make it a little bit easier. And then we would try to find side C. So sine of big C over little c equals sine of big A over little a. And now we're back to doing what we've done before. And when you do your cross multiplying, you should get that side length. Now this is the one option. This can actually be drawn with B being obtuse. Now if it's obtuse, then angle B would not be 65.819 or 65.8 if we just want to kind of round it to make it a little bit easier. Instead of it being 65.8, I'm going to subtract it from 180. And now we're going to think of, so we're going to say, if B is 114.2 degrees, what would happen? Well, we'd be able to find angle C. Angle C would now be 22.7. Okay, so we now have a new angle B and a new angle C. So there's always another option when we're given a side-side angle. This is why we had to be really careful in geometry of saying that just because we know two sides in an angle, that we know what that triangle is going to be, because side-side angle is not a guarantee. Side-side angle actually gives me two different triangles. So that's why we never used angle side-side in geometry. So the next step would be to find little c. So sine of big C over little c equals sine of big A over little a. Sine of 22.7 this time over little c. Then sine of 43.1 over little a. Whoops, little a was 186.2. And if we do our cross multiplying, you should end up with 105.164. Next example. I know angle A and side A, side B. So side angle, can't guarantee anything. So I'm going to use sine of A over little a equals sine of B over little b. So sine of 45 over 9.9 equals sine of B over 7. Multiply both sides by 7. So now I would need to use the arc sine of 7 times the sine of 45 divided by 9.9. And notice it's giving me an acute angle. 29.998. I'm going to round that up to about 30, just to make things easier. Now, if we use this angle B, then our angle C would be 180 minus 30 minus 45. It would be 105. Then we would find side C. So I would do sine of 105 divided by little c. I think I would use angle A and little a and do my cross multiplying. So I end up with 9.9 times the sine of 105 divided by sine of 45. And little c is 13.52. 0.24. Notice on the angles, I'm kind of okay with going 1 decimal place. The sides are where we want to have the more the merrier. Now, that's one option. The angle B is 30 degrees. But that's not the only option we have. So one option was that angle B was 30. The other option is that angle B is obtuse. So angle B would be 180 minus 30. Let me write down what all we had on that other side, because it should have been all on the same page, and it just didn't copy that way. Now, if angle B is 150, what would angle C be? So it'd be 180 minus 45 minus 150. I got a negative 15. Can that happen? No. So this is impossible. So this one, I mean, we could draw 2 triangles, but this one just didn't work. So there was only one option for this. All right, our last example of using law of sines. I've got, and it's kind of hard to see what's going on. So a bird is perched on top of a pole. Here's the bird. On a steep hill. And an observer is located at point A on the side of the hill, 110 meters down from this pole. The angle of inclination of the hill is 50 degrees. So from horizontal up for the hill, that's 50 degrees. And angle alpha is 9 degrees. So I'm going to just redraw this little triangle. This is 110. This alpha is 9 degrees. And I need some more information. I need at least something else. So I want to show you something interesting. So this right here, that is actually a right triangle. I'm going to redraw it because this is horizontal and vertical. And this little angle is 50 degrees. Well, I can find this little angle to be 40 degrees. Well, if that's this right here, that's 40 degrees. Well, notice if I think about this, that's horizontal, I mean like flat. So 40 here would mean inside here, this little angle would be 140. Find the distance from the observer to the bird. So we're trying to find that. So I'm going to call this angle C. So this would be little c. And I know little b. Let's see. If I know angle A and I know angle C, I know angle B. So 180 minus 140 minus 9. Got 31 degrees. So this angle right here is 31 degrees. So I know angle B and I know side B. So I know I'm going to use angle B and side B. I'm trying to find side C. So angle B was 31, side B was 110, angle C was 140, and we're trying to find side C. So do a little cross multiplying. And I get 110 times the sine of 140 divided by the sine of 31. $284 meters.